Welcome to this video lecture on the subject Basic Electrical and Electronic Circuits. In this lecture, we are going to discuss about JFET, Junction Field-Effect Transistor. So what is the need of JFET? So these are three-terminal semiconductor devices commonly used in amplifiers, switching circuits, oscillator and buffer circuits. What is JFET? So JFET is a voltage controlled device. It is a unipolar semiconductor device, consists of three terminals, gate, drain and source. So here the current flow is controlled by the reverse biased PN junction. So through a gate voltage controls the drain to source current. So it is identical to a water pipe. Like water flow depends on the valve, here the gate voltage controls the current flow from the drain to source. Types of JFET, it is classified to N-channel JFET and P-channel JFET. Here in N-channel JFET current flow is carried by the electrons. So in P-channel current carried by the holes. So these are the symbols of the N-channel and P-channel JFET. So the N-channel JFET, here the N-type semiconductor material is used as a channel type and current is carried by the electrons. So this type is most commonly used because the electrons have higher mobility. So here the gate is connected to the P-type semiconductor material and drain and source is connected to the N-type channel through ohmic contacts. And P-channel JFET, here the channel is made up of P-type semiconductor material and gate terminal is connected to the N-type semiconductor. Drain and source is connected to the P-type channel. Working of JFET, here it is normally operates in depletion mode. So it is normally when no electric field is applied, it is normally on. When negative electric field is applied to the gate terminal, so it changes the width of the depletion layer and the current flow is modified. Working of N-channel JFET, in this diagram, so N-channel JFET circuit diagram is given with power supply VDD. It is connected to drain and source and gate terminal is connected to P-type semiconductor. Here the channel is N-type. Current flows from the drain to source through this N-type channel. So when gate is reverse biased, when increasing the reverse gate voltage, it will narrows the channel. So depletion layer width will be increases. So due to this current flow will be controlled. So at pinch of voltage, the current channel becomes very narrow so that the current becomes constant. So the increasing the reverse gate voltage reduces the drain current. And working of P-channel JFET, so in this diagram, gate is connected to the N-type semiconductor, drain is kept negative with respect to source, gate is reverse biased using the positive voltage. So increasing the positive gate voltage will narrow the channel. So at the pinch of voltage, current becomes constant. So this is the working of P-channel JFET. These are the drain characteristic curves of the JFET. So in this diagram, characteristics is shown for the drain current versus drain to source voltage, ID versus VDS for the applied gate to source voltage. For the various voltages of gate to source voltage, the characteristics curve gives the ohmic region, pinch off and active region and breakdown region. So when the gate to source voltage reaches 0, so it is gives the maximum ID, and when we are applying a negative gate voltage, it reduces the drain current. So this region is known as the pinch off or active region, in which FET acts as the amplifier. Let's take the assessment questions. For normal operation of a N-channel JFET, the gate source junction must be forward biased, reverse biased, unbiased, connected to the drain terminal. So for the normal operation of N-channel JFET, so the gate to source junction must be reverse biased. The answer is B. Why does a JFET exhibit significantly lower noise characteristic compared to a bipolar junction transistor? It operates in much higher voltages. It does not utilize any semiconductor material. It has no carrier injection across a forward biased junction. Its physical dimensions are vastly larger. So because it has no carrier injection across a forward bias junction, it provides a very low noise characteristics. So the answer is C. Thank you for listening this lecture.